probably try to plan for a longer exposure during the time, so we don't have to go back and forth with changing targets as often. That's assuming weather's nice to us, but we'll see.
And Raphael, if at any point you're able to bring up OBJ1 spectrum, I would love that. Love to see it.
Yeah, I think Richard could actually do that pretty easily.
Thank you, Richard.
We could check really quickly which observation it is. It would
Yeah.
be number 5029 in the blue.
Okay.
How do you see that? Curious.
We have the observation log, and it's as long as we keep track with both of them, we can check one of them and it has a target name, and then we can just pull it up. Yeah, it's a highly redshifted galaxy, so the blue side looks like nothing, but the red side, which is 5027, should look better. Okay, yeah, it's a very faint galaxy, but there is a bit of a trace. And then I think you can take a row slice. No, wait, this is red. So take a column slice of if you take it right where the trace is.
Oh, sorry.
Yeah,
Yeah.
right there.
I see it.
Then you can kind of see the spectrum.
And I see an emission line a little lower down where it crosses the night sky line. If you could zoom into that a little lower, even lower.
Yeah.
Right where it's crossing the bright line, right there. There's an galaxy emission line there. If you zoom in, if you can center and zoom in, so clicking on the middle button should center there.
Yeah.
So,
No?
no, I didn't see something like that.
Just missed that window. The control on the top right will also let you zoom in. So I think try 2. Okay, and then you have to kind of scroll around. One way to do it is either there or on that cord again. The green, like the little black box, is what you're currently looking at, and then you're in the green box. So you just have to kind of go for it. You could also
expand it a little bit.
Yeah, expand it a little bit. I wasn't really sure how zoomed in 2 would be. Seems out.
Yeah, 1 is good.
Yeah.
A little bit lower. A little lower even. I don't see it now. I'm not seeing any emission lines associated with the galaxy.
Okay, here's what we can do. Zoom back out again. And I think if you mouse over on the spectrum, it tells you the pixel. Yeah, so it's column 620-ish, right?
Yeah.
Mm-hmm. And row 1390.
Or row 1390, yeah. So now...
Actually, if you zoom in now, what does it do? If you go to 1 now.
I'll look for it again. 1390, yeah. So it's there-ish. It's just when you zoom in, yeah.
I don't see it. I think that was just an artifact of binning. I don't think there's any emission line there.
Just looks like contrast.
Wow. So this galaxy, anything on the blue side at all?
No. The blue side looked pretty faint. What's there now? I mean, we can, try to take a row of that right there. That might just be detector noise, though.
I'll zoom in a bit just to see if I can.
I don't see any continuum. You're right. I see I see a little bit of continuum. It's very faint.
Yeah, there might be
right
something.
there, your cursor. I don't see any emission lines. Wow.
Yeah.
So this galaxy, basically, I don't see any emission lines on the red or blue side. It'd be hard for them to get a redshift.
Yeah. Extraction might pull something out, but
I'd be very surprised when you can't. And this is a single exposure?
Yeah, this is one exposure. We can go into the next one.
I think that might be good because the sky got darker. If you go to the
Yeah,
last of
so
the exposures, that would be west, actually.
31, I think, would be the last one on the blue side,
Yeah.
and then 29 on the red.
Okay. Wow, nothing there.
Nothing prominent. And it would be pretty smeared out if it was a galaxy, so.
Yeah, I can see the continuum of the galaxy, but I don't see any emission line.
Mm-hmm. Just the skylines. Right, the log scale on the controls.
Yeah, let's try that. That might be helpful. Or try histogram equalization. That's usually good.
It still looks
Try
mostly just
log.
like the
Yeah, sure.
skylines.
Try log.
Yeah.
Try histogram equalization instead of HEQ box. Let's see what that does. Sorry, the upper one, the one above that. Histogram, yeah, that one. Yeah, don't know if it'll make a difference. Same thing. So this is interesting. We're seeing strong continuum from the galaxy, but I don't see any emission lines.
Nothing that's strong.
But you know,
for sure.
the good thing is we got continuum, and the galaxy doesn't have emission lines. There's not much we can do about it.
Mhm.
Now, what might happen is with the reduction of the data, they might be able to get some absorption lines of the galaxy. That's much harder to see, of course, in the raw data.
Like on the column slice you zoom in on the continuum, just kind of ignore the very big peaks.
Yeah, it's very hard to see it before sky subtraction, but after
Yeah.
sky subtraction, something may emerge. And it won't be a single absorption line, but you know, there'll be a pattern. If there is absorption, there'll be a pattern, and that might be.
Mhm. Sometimes
No.
something I'll sometimes do is on that like little plot box, you can make it big.
Yeah.
And then shrink it back down to a size that's more reasonable later.
Right.
If you like grab the corners of it, you could make it huge.
Yeah.
And then you can zoom in on portions of it by like clipping it essentially.
By what, sorry?
You like drag like a you're
Oh,
yeah, like that.
Yeah.
I'll
do a bigger bit.
And then there's an apply box button on the top right.
Yeah.
And that lets you zoom in. And then if you want to get out of that, you can hit the no zoom button, which is underneath it.
Yeah.
Cool. This is also very helpful for the arc lamp calibrations when you're trying to get the pixels of the particular lines and making sure that they're in the right spot.
Yes.
I'll zoom in on the features and make the box really big because I do most of it on this tiny little laptop. So I don't have the biggest screen to work with, so I have to make it huge. But yeah. Yeah, I can't see anything from this really. It's mostly
Yeah, I'm not
skylines.
seeing anything. Yeah, I mean, it usually is visible in the 2D spectrum if there's something there, but I'm not seeing anything. That's okay. This is what we have. The one possibility is you see there, you know, most of the lines are narrow, but there are two broad lines. One of those is
far left.
one in the far right, and then there's one in the far left. Where's I'm just curious where the broad line is on the left. I think that might be real. Can you get a
Think
pixel number for it? You know, I mean the broad,
temporarily,
that peak, that's the peak, yeah.
yeah.
This one, yeah.
Mhm.
Can we, I wonder if we can go to the corresponding part of the 2D spectrum.
Eight, 7.
Because what I'm seeing is something that's broad, but not very tall.
I think it's gonna update the image as
Yeah, I
well.
was
So
thinking it will update, so I'll just
yeah. Okay.
it's 5029. I think.
Mhm. Yeah, 29.
So,
You can zoom in on the region and really in on that peak. Yeah, little double peak. Yeah. It's like 3154-ish, or that's after. 2960, I think.
Yeah, that's the line. What is that? That looks like oxygen too, if you ask me, in the galaxy. Whereabouts, can you tell what the column number is? Sorry, row number is? I think that's oxygen too.
in which, so in the plot or the 2D?
I wasn't here for the calibration, so I didn't do them myself, but last time I did write down the wavelength and pixel spacings.
But I mean, we have a pixel number here, right, for the 1D
Yeah.
spectrum. If we went to the corresponding pixel number in the 2D spectrum, could we zoom into that?
The X or the Y that we're hoping for? 2953, right? Or 1077?
I thought 1077.
Yeah, down a little bit, I think. Make it a little clearer. Yeah. Between all those very strong
Yeah.
skylines, maybe.
I see. What is the pixel number of the where the peak is, roughly, the row number?
1077, I think.
1037, okay.
Yeah.
What about on the 2D? Where's 1037?
Sorry, 1077. Sorry.
Is that there?
Yeah, that'll be there. Yeah.
Because what I'm confused about is you see lots of night sky lines there,
Right? But there's
and I'm not seeing that many peaks. This looks like in a much more clean part of the spectrum.
Yeah, so is it at the top then? Is it the other coordinates then?
Move your cursor left and right about the peak, but kind of keep it level. Okay, yeah. So we want the X numbers,
Oh, it's the
29.
other way. Yeah.
Yeah.
That's
My
fine.
bad.
That makes a lot more sense.
Yeah.
Yeah.
We want, so it's like 2955.
Yeah.
Cool. Cool. So that's probably at the top of the
In
spectrum.
the
Yeah.
top upper part, that makes sense because there are
Yeah.
not that many night skylines there.
So it's there, that one.
Pretty
Can we
bright
zoom into
around
that?
there.
Yeah.
Maybe we should go back to like log or linear. It's pretty bright.
Yeah, you're right.
Okay.
Yeah.
Do you think that doublet is that doublet?
It might be. Yeah, I mean it's around the same spot, right?
Yeah.
Then that's clearly it extends all the way horizontally. So it's a night skyline, nothing to do with nothing to do with a galaxy. I was hopeful. So you can see the two weak lines that are higher up. Do you see the two weak lines? Yeah. If you look at their y coordinates, I bet they line up with the two weak peaks in the 1D
Towards the
spectrum.
left, yeah. So that's 30, 55 and 30, 30, I think.
30, yeah.
30, 30 and 30, 50, okay. Oh, just keep zoomed in the prior.
Yeah, keep it zoomed
Oh,
in. Yeah,
sorry,
keep it-
right, right. Yeah.
It's okay. Go back to it.
And you see those two very shallow, shallow peaks. Yeah, those two. I bet those are those
there
two.
they are. Yep. 30,
Yeah,
50
yeah.
and 30, 30.
Okay. So this completely confirms that this double peak thing is associated with the sky because it extends horizontally. It doesn't, not limited to the galaxy's continuum. Thank you for getting this spectrum. We'll, Lodrick and X will be super happy. You guys must be on to M31 by now, for a long time now, right?
Yeah, we got to get to M31 pretty early tonight.
Did you have a gap before M31 was up?
Yeah, like an hour or two, I think.
No targets at all?
I think we just did one transient, yeah,
We did,
Got
yeah,
before between
transient.
the first FRB and
Got you.
M31 coming up.
Good. You had something there. That was a so it was a non-M31 transient.
Yeah.
Richard, I don't know if we've met before. Tell me a little bit about yourself, please.
Yeah, I don't think we have. Yeah. So started working with Monica three weeks ago now. Originally did my PhD at Belfast, in Northern Ireland, looking at binary Trans-Neptunian objects in Hubble archival data. So
Gotcha.
characterizing the colors and surfaces, etc.
Wonderful. And are you located in Hawaii then?
Yeah, I'm in Hilo. Yeah.
Beautiful. So is Jamaica. And Stefan, I guess you're in Kona, right?
Yeah.
Oh, and Raphael, I was talking to Charlie Sakari yesterday. She was hosting an STS session.
Cool.
Yeah. In fact, last night was the first time we had two completely different groups host STS sessions. Charlie and Matthew Chatron were one of the groups, and then John Amera before that.
Yeah, Charlie's kind of my liaison between doing work on salvation and finishing a thesis at SFSU. So it's
Great.
cool.
And Charity must have started classes there.
Yeah, I think I've actually seen her in a few, or in 701, if I remember correctly. So that's our like classical mechanics class.
Are all classes fully in person now, or are they hybrid?
Yeah, they're full. So classes are technically fully in person, but there's still some classes that are working hybrid schedules, but they were classes that already
Got
had
it.
hybrid schedules.
Okay, that's us reading out now. So I'll send the next target coordinates.
All right.
Yeah, sending them now.
Got it. And we're moving. Let me know that PA when you got it.
Yep.
Oh, there's a mistake on the deck for this one as well. The 4 didn't make it.
Oh yeah.
42.
All right. This is a new target list that I made earlier today, and for some reason, some of the fours didn't quite make it. So I will be
I'll
fixing that.
resend.
What's the PA for this one?
Yeah, so I just put it in now. 88. 88.
Got it. And can you narrow the slit?
Oh yeah,
Thank you.
there we are.
All right, we're guiding. You can open the slit up and take data.
Great, thank you.
Yep.
Yeah, so we're here for 45 minutes. So
Okay, great, thanks.
So this is what I assume our last M31 target. I guess we
No,
could
we have
probably do
another
like
hour.
brighter targets. After, I
Oh,
guess,
right,
yeah.
because we have the other target. How long are we exposing on the?
That was another what is it? 1200 seconds, 20 minutes.
20 minutes. Yeah, we can do at least one more M31, I think. As long
Yeah.
as it's a brighter
Okay.
one. And then
Yeah,
we could do the fast radio burst and then
yeah,
final standard and then call it a night.
I
Cool.
was thinking, is it worth trying to do a few of these?
Yeah, the
top
brighter
group?
blue ones.
Yeah.
Mhm.
Yeah, but typically I think the shorter exposure times usually we've done more often anyways. So
Oh, okay.
True.
yeah.
Uh, I guess we can check the number of epochs for those in particular. And there's always tomorrow night as well. Looks like we don't have any like a set plan for tomorrow night anyway. So
So if we go for this 500 second, 3 times 500 second one next, or a bit shorter.
seconds, 15, so 25 minutes, and then 20 minutes, and it'd be 5. Yeah, I think 500 seconds is fine.
Yeah.
Let's do that. about 6 o'clock is when we want to end. So it's about 45 minutes of exposure time and 15 minutes to slew and read out. So I think that's plenty.
Oh, yeah, got two more questions in the chat, which I am not currently qualified to answer, so I'll pass them on to someone else.
Yeah, I could answer. So how do we choose the targets? We have a really big master list that Monica set up years ago in 2019. And we basically queried this alert broker called Antares, and it goes through all of ZTS alerts and it adds some like contextual information to them. And we set up particular tags. I should say we, Monica, set up particular tags. She was also working with a bunch of other people who were integral to developing Antares. So she knew what she was doing. And yeah, so she set up this big master list, and then we went through, and there's some that were completely unclassified, which basically means if you were to look them up in Simbad, which is a big what's it called? I'm going to call it a database for now, but it basically pulls together a bunch of information from various sources, surveys, papers, all that stuff. And so if a star has been looked at in a particular area of the sky before, you can pretty much guarantee that Simbad will tell you if it's been observed and classified. And so for the unclassified ones, if you look up their coordinates on Simbad, pretty much nothing comes up, or only like minor things like, oh, this star was in a survey, but we didn't really do anything with it. So we're focusing on those stars in particular, or at least I am for my thesis. So we're focusing on those for first classifications, but we also have another subset of red and blue stars, which emit more light in red or blue wavelengths. Yeah, so those are our main sample, and we look at the light curves to make sure that they're actually interesting and they're doing something somewhat of value to observe. Cool.
And Rafael?
Targets.
So I guess the ZTF is on the Palomar 60-inch, is it? 60-inch telescope. This is a great example of something that is, the people aren't collaborating in this particular instance. Not exactly. It's not like we're working with the ZTF team, but it's two surveys that are feeding off each other. So ZTF is an imaging survey. It takes images. And in fact, it takes two images and it takes a difference between them. So anything that hasn't changed should subtract off, but anything that has changed shouldn't subtract off. So they do that. And then, as you said, Monica developed the Antares broker. That is a piece of software that goes through time domain data like that, like ZTF, and identifies things that are potentially interesting classes of variables. And then your telescope tonight is good at taking spectra, so it's a great collaboration. Really between three things: a survey on one telescope, a piece of software, Antares, and then your spectroscopic telescope.
Yeah.
And then the blue and red, what happens is, this is an example, Kast is an example of something called a double spectrograph. So double meaning, as soon as the light comes in, one of the first things it encounters is a 45-degree piece of glass. It's called a dichroic. And light that's longer than a certain wavelength, in this case, you're using D55 as the dichroic, or D46?
57.
D57, okay. So light whose wavelength is longer than 570 nanometers goes straight through that 45-degree piece of glass. And light whose wavelength is shorter than 570 nanometers reflects, does a 90-degree change of direction and goes in, and they go into two different spectrographs and get captured that way. Sorry to interrupt. I just wanted to explain that.
It's all good. Yeah, it's kind of funny too because there's the dual channel of the spectrograph. So that's kind of the red and blue that we're talking about sometimes. There's also red and blue stars in our sample that we talk about sometimes. So it's
Right. Those are two different things.
yeah.
What happens is, in this case, when we're talking about blue and red channels, there's really a sharp break. Everything longer than a certain wavelength goes into the red channel. Everything shorter than a certain wavelength goes into the blue channel. Whereas when we're talking about blue and red stars, stars put out light at all wavelengths. It's really talking about where most of the light comes out. So it's not as sharp it's not like a blue star only puts out blue light and no red light. It just puts out more blue light than red light, and reverse for a red star. If that makes any sense.
Yeah. Good question. Is it on the list? Gonna have to look at emails for that. The little shooting star on the sky cam. Or all sky cam, I should say. Yeah, it's one of my favorite cameras too. But I don't.
And to answer Jamaica's question, I think the second FRB will be something they've called OBJ2. There are two bright FRB hosts that they've asked us to observe. One was observed at the beginning of the night, and the second one will be observed later tonight, the end of the night.
Is it that they found these fast radio bursts, they think, and they're trying to see if there's a host galaxy there?
They've even found a host galaxy. They're trying to measure the host galaxy redshift.
That makes sense. Yeah. So if you have some absorption lines or ideally some emission lines, that'd be pretty easy. Makes sense.
Yeah.
Cool. Cool.
And even if the fact that you've detected continuum, even if you don't detect emission lines, it rules out certain wavelengths, right? It rules out certain redshifts, sorry. If the redshift were such and such, we know certain common emission lines in galaxy spectra should show up at certain wavelengths. So this suggests to me that this galaxy is at a relatively high redshift, greater than about 1 point, I would guess something like 1 point, greater than about 1. Because what happens is when it's galaxies have this emission line at 3727 angstroms. Now, and shortward of that, they have hardly anything until you get to Lyman alpha, which is at 1216. So 1216 to 3727 is a huge, so a factor of 3 in wavelength. It has nothing. Galaxies have very little. Now, you can see if the redshift is greater than 1 plus z is 2 then, or let's say redshift is 1 plus z is 2 multiplied by the rest wavelength, 3727, becomes 7454. And that is beyond the red edge of what we can observe. So you can see that we can get some redshift constraints that way. Even if we don't detect an emission line, the lack of anything obvious tells us that it has to be greater than this redshift. And we, with OBJ2, we may actually detect an emission line. We'll see.
Let's see.
I might try to get a spectrum of this thing with Deimos in October if it's still, because it's a galaxy, right? So I can get its spectrum and see if its redshift is higher than 1, because Deimos has a much longer wavelength coverage all the way to 9,000.
Nice.
I'll offer that to X. We have Deimos time in less than a month. Actually, on the 6th of October, coming up in a few weeks. We can do the same thing, like at twilight, we can observe it.
Nearly up. We're like halfway through the month. That's crazy.
Yeah. Raphael, the amount of traveling I've been doing of late has been insane. I thought I was busy before, but boy, it's been crazy, the amount of travel. I spent 19 days on one trip in India,
Mhm.
like 6 cities.
Wow. That's
And I came back and then I immediately went to another place, and then tonight I'm traveling again. And so it's been insane.
all over the place.
All over. India and then Indiana.
Mm.
Very confusing. And then now Cambridge, Florida, sorry, Boston, Florida, and no, Cambridge, Florida, and New York in quick succession this coming week.
Wow. So lots more traveling to do.
Lots more traveling.
Ouch.
Then Hawaii in October, and Portland and Spokane all in October. So really crazy. November, I'm going to New York again. It's crazy. Mika, it's super late for you.
Yeah, yeah. I wanted to make sure that I stayed to the end to round out these 2 sessions with the Salvation team that I thought. So I apologize for that confusion. I will
Oh,
send
no, it's my
a
fault. I was
follow-up.
really very last minute.
But it has been an enjoyable experience shadowing the team, and I'm certainly looking forward to the next one with the students from India.
It'll be early morning for me on the East Coast. My flight's supposed to land at 5 a.m. And by 6, I hope to be on Zoom in Cambridge. And it'll be 3 in California and midnight for you.
Right.
And I think the India, at least one of the schools will join half hour into the STS session, 4 o'clock their time, which is 3:30 Pacific.
Okay. Okay, so we'll have a bit of a staggered entrance. So that'll be nice. That'll be nice. It'll give a chance for the first group to kind of get settled and comfortable with interacting with the group before it gets larger.
Right. In fact, Minu said they will connect, I suggest they must, let's see, I had suggested 4 o'clock to them. So I think they will also connect at 4. So the 2 schools will all connect at, sorry, 4, I keep saying 4. 4 p.m. IST, which is 3:30 Pacific, 3:30 a.m. Pacific.
Okay.
The two schools will connect at the same time. I saw that you shared the link with Minu. I'll just write to her to say that ignore the date on the link, that we are talking about Monday, the 18th. Oh, actually, by the time she accesses the link, maybe it already have the new date.
Exactly. As soon as we wrap up here with this shadow session in about 3 minutes, I will update the link.
Thank you. Thank you, Jamaica.
No problem.
I'll write to Minu and I'll CC you to say, about the age range. I'm going to recommend grades 10 and 11 and possibly 9 and 12 as well if they're free. I guess 18-degree twilight is at 5:21 a.m. is what I'm seeing.
It's starting at 5:20 and then ending at like 5:54-ish. So that gives us until about 6. And the last 6 minutes are the standard.
You guys, I'm gonna hang up. Okay.
Roger. Have a nice night. Or morning, almost.
Yeah. You guys have a good day,
Thanks.
evening,
Thank you. You too. You too.
Sleeping.
Thank you, guys.
next 24 hours, I guess.
Oh, you guys have been terrific. Thank you.
Yes. Thank you so much, Salvation Team, for allowing us to shadow you yet again. And I certainly look forward to our upcoming session in 24 hours.
Yeah.
Take care.
You know.
Bye.
Safe travels, Raja. Aloha.
Right.
Stop recording now as well. Who's the? It's Richard.
Yeah, sorry, stop recording.
Mhm.